So hi guys, welcome back to my channel. So in this video I will discuss problem A and B of Codeforces round 899. So let's get started with problem A. So what the problem A is saying, in this problem you are given an array of length n, and what we have to do, we have to construct another array of same length. So we have to convert, we have to generate another array, and another array should be a good if these three conditions are satisfied. The first condition is all the elements of this array B should be positive integers, like should be greater than equal to 0, and this array should be sorted by default, like it should be in increasing order, strictly increasing order. And one more condition is if a of I not equal to b of I, like for all I from 1 to n, a of I not equal should not be equal to b of I. So what we can do in this problem, so let's see solve this using an example. Let's say this is our example 1 3 2 6 7. It is a very good example. What is the example? 1 3 2 6 7. 1 3 2 6 7. So the first condition is all the elements of array B should be greater than 0. So what we have to do in this problem, basically we have to minimize the value of Bn, and we have to return the value of Bn, like the last element of our new array, and that value should be minimum possible. And because that value should be minimum possible, what we can do, we can take the value of b1 as 1, b2 as 2, and bn as n. So the value of bn should be at least n, and it would be greater than n if these conditions are restricting is it. So greedily what we can do, we can take the value of first element as 1, second element as 2, third element as 3, fourth element is as 4, fifth element as 5. But the condition is this condition should be satisfied, like for all I these values should not be equal, and you can see it is restricting it here. The value of b of I could not be equal to 1. It should be greater than equal to 1 or less than equal to 1. So if we take it 0, because we can't take it 0, because all elements should be greater than all elements of our new array should be a positive integer. So what the condition left is, we have to take the value of bi as 2, and when we have to take the value of first element as 2, what we have to do, we have to take the value of second element as 3 at least. And if let's say if we take the value of b2 as 3, both the values will match. So we can't take value of b2 as 3, we have to take it 4. And similarly we can't take as 3 here, because 3 will be less than 4. So we have to take here 5, and we have to check if 5 not equal to this condition is matched. So 5 not equal to 2, and then here we have to take 6, because 6 is greater than next element after 5. But we can't take 6 because 6 is matching to this ith element, same ith element should not match. So we have to take here 7, and here we can take 8 because 8 is not matching to this value. So it was a very simple question. We can see the solution of it here. You can see my solution here is accepted. So what I did is, this is my input, and what I was doing, I was making my value of current will be finally this one. So what I'm doing, I am initiating my current as 1, and as I am going from I equal to 1 to n, if value of a of I is equal to current, then I am making it plus plus, like it should not be equal, this value should be next. And now what I am doing here, why I am doing curve plus plus here, because for the next value, like uh, let's say these values were matching. Let's say it was 3 here, 3 is matching to this one. So what I am doing? I am doing 3 plus plus. So my 3 will be 4. As you can see, 4 is here, and this is I am doing here. And why I am doing here plus plus? Because after it I will go to this position to the next index, and for it I have to do plus plus. So where I am doing plus plus, for this I am doing plus plus here, and simply I am printing cur minus 1. Why I am printing cur minus 1? Let's say I have reached to this position, it will be my final answer. But after reaching it, it will also make it a plus 1 here. So it is making it 9. So for that I am doing it minus 1. So this was the solution of this problem. Let's see the second problem. So it was a very interesting and a little bit difficult but not much difficult problem. It was a nice problem. I also got a wrong answer on this problem. So what is given in this problem? We have given n different arrays, and what we have to do? We have to select some arrays from n different arrays, and after selecting them, we have to select some different arrays from our complete array all arrays, such that the maximum number of elements in our final array should be maximum possible. Let's understand it with an example. Let's understand it with an example. Just a sec. That's all. Let's say this is my answer. Let's say this is my these are my array 1, 2, 3. This is my first array. 4, 5, 4, 5, 3, 4. These are my 3 arrays. Okay. So what we have to do? We have to select a some arrays. Let's say I select first and second array, and after selecting it, we have to put all the elements of these two arrays in my final array S. And what we have to do? We have to increase the number of elements in this array. Like different distinct elements should be maximum in this array. So what is the condition? The condition is if I select to make distinct elements maximum, simply we can select all the arrays, and it will always contain all distinct element, and it will be maximum. But the condition is all elements should not present in my S. This is the main condition that is present in it. So what I was doing here, not what I was doing, like solve it using how can we solve this problem. Okay, so this was the main problem. All elements should not present in my final array S, and what we have to return in this problem was simply the maximum number of elements that could be present in S, and all elements should not be present in it. It simply means all elements for my all arrays should not present in my final array S. So just a second, let me erase some these. It's all resolved, all erased. Okay, no problem. So what I was doing, let's say this is my array. Let's rewrite it again. Writing it was 4, 5. 4, 5, 3, 4. So how can we solve it? Let's say I take first array and count all elements. First of all, what we can do, we can grab all these arrays and count how much distinct element are present in it. So let's say I have counted, put it in my final st set, and st is a set which is used in STL of C++, and it will contain number of all elements, all distinct elements which are present in all different arrays. And what I will do, I will make my as, and I will insert this array in it, and we will count if not equal to this, then we will insert this array also, and we will count if not equal to this final st, and if it's not equal to, then we'll go again. So this is the general approach which I think is startly, that's why I got wrong answer. But anyways, let's solve it using another approach. uh, let's say my first element is present in how much arrays? My first element is present only in first array. Let's say my second element is present, second element, this element is also present only in first array. And what I am doing, I am making this adjacency list. I am counting where this element is in how many different arrays this element is present, and 3 is present in 2 different arrays, first and third. Similarly, I am making my adjacency list for this, where and where 4 is present. 4 is present only in second and third, and where is 5 present? 5 is present only in second. So what I will do, I will try to erase only a single element from my final S, which will uh, move ahead me to make maximum number of different arrays, no, maximum number of different numbers which can be get. So let's say I am erasing only first element, like I want to erase only this single distinct element. So what I have to do is, for erasing it, I have to remove all the elements which are present first in first array. So what I have to do, if I want to erase one, then I have to take arrays such that uh, we can take these two arrays, because these are different. And if I want to take a second element, if I don't want to take second element and I want to take all other elements, then what I have to do, I have to erase all the elements of first array. And similarly, if I don't want to take the third element, then what I have to do, I have to remove, I will not take all the elements of these two different arrays, first and third array. And similarly for 5 and 4 and 5. So for all these values, I will take my maximum value, and because it's a brute force, so it will take O of n square time complexity. And because since the value of n is only up to 50 and the value of all elements is also up to 50, it will not go beyond n square. So let's see let's see its final accepted solution. I know it's a little bit of large. Let I have, this is my input, it's my input up to here. What I'm doing, I'm making my adjacency list, and I am inserting my uh, array index where this value is present, in which array this value is present. So this is my adjacency list, and this is my final vector factor, like 1 2 3 4 5 3 4. This is my vector factor. All these arrays are present in this vector. So then finally what I am doing, I am sorting my adjacency list, and then what I am doing, I am starting from 1 to 50, and because the value of these are starting from 1 to 50, so that's why I am going from 1 to 50. And if the adjacency of I dot size is 0, it means there is no, it means this ith element is not present in any of the list. And then what I am doing, I am starting from 0 to n. I am starting from 0 to n, and what I am doing, I am performing binary search in my adjacency of ith array. Remember it, it's adjacency of ith array. I am performing binary search. If this array is present in it, like what I am doing, let's say I am going from 1 to n. I will take all these elements, all these arrays in my final array, except those which are present in it. So I am making binary search in this array, and check if this ith is present in it or not, and if it is present then I will not take it simply. So that's why I am performing binary search. If it will returns true, then I will simply continue. That means I don't have to take any element of this array. Then what I will do, I will simply, if uh, this this array is not present in my adjacency of ith value, then I will simply go to all elements of this array and I will insert them in my final answer. And then simply after all of this is done, then I will make my answer equal to maximum of answer comma size of this set, and I will take it for all values, and which will return me maximum answer. That will be my final answer. So that's all about this solution. So thank you guys if you see this video up to now. So bye bye, take care, see you in the next video. If you like the solution, then please like this video